Hello children, this is Edison. In this video, we are going to discuss about the chapter Applications of Derivatives, Part 3. The topics will be covered in this video is maxima and minima. We have heard this word in our real life situations itself, in the profit. Every businessman likes to get the maximum profit. They like to invest very less. That means a minimum amount they want to invest and to get the maximum profit. Okay, children. So like that we can say. Even here, when you throw a ball, it goes up and comes down. That means for your force, it reaches this much maximum. Okay, this much maximum height. Okay, children. It reaches the maximum and comes down. Okay, and also children, if I consider the enemy's helicopter moving in the form of curve. Okay, but you are here, you want to shoot the helicopter. What will you do, children? Okay, you want to shoot this helicopter means you have to suppose wait till it comes to very close to you. Okay, that means what? You have to get the nearest distance. That means if it is coming in the minimum distance, you can shoot it. Okay, children. These are all actually real life situation problems. But how to find maximum or minimum? If the function is given like f of x is equal to some x square plus 3x, then will you be drawing the diagram and then see that here at this point it reaches the maximum. Here at this point it reaches the minimum. It is very difficult without drawing the graph itself we can say. So there only our great calculus taking place. So then by doing the derivative test we can say at which point this function will reach the maximum or at which point the function will reach the minimum. Okay. Now see children, the first derivative test. You have to find the f dash of x for the given function. F of x will be given. From this you need to find f dash of x. Okay children. So then you have to equate to 0 and get the x value. Then if x value is like a c. Okay. Before c, that means c minus. After c, c plus. You substitute the value in f dash of x. So that means f dash of c minus. Okay, and also you can substitute f the c plus value. Okay, so that means children, if it is the f dash of x value sign changes from positive to negative, that means this is greater than 0 but this is lesser than 0. You know what will happen, children? It will reach the maximum at c. The c minus gives you positive, c plus gives you negative, means we can say the function reaches the maximum at c. Okay children. Similar way here, if you get f dash of c minus lesser than 0, f dash of c plus greater than 0, that means negative to positive means we can say that it reaches the minimum. Is this clear children? Yeah. If you don't find any changes, that means what? F dash of c minus is lesser than 0. F dash of c plus also lesser than 0. Another case, f dash of c minus greater than 0. F dash of c plus also greater than 0. Now, children, we don't find any sign changes. It remains same. So, if you don't find any sign changes, means we can say there is no maximum nor minimum. That means that point C is called what? The point of inflection. Okay, that C is called the point of inflection. Okay children, so this is how we should do the first derivative test to check whether at C is maximum or not. Second derivative test. It is actually very easy children. The function will be given f of x. You have to find f dash of x and also you find f double dash of x. You do this too. And then to find whether it is maximum or not, what you have to do? F dash of x you have to equate to 0, then you will get the x value. Just substitute in f double dash of x Okay, the value should be substituted in f double dash of x. If it is lesser than 0, we can say it is local maximum. Okay, if it is greater than 0, we can say it is local minimum. Okay, children, this is what even after you doing this one, now f double dash of x, if you substitute now, if it is equal to 0, here it is neither maximum nor minimum. Okay, neither maximum nor minimum. Okay, children, that's what here you can see at C. Okay, we have to substitute and f double dash, is less than 0, so we can say it is local maximum. Greater than 0, therefore local minimum. Equal to 0, there is no maximum or a minimum. That time we have to go back to the first derivative test to check it. Okay, children. Let us take the example, children, to find the maximum and the minimum at particular points. Okay, so that means, so then here we are going to use the first derivative test. I just take f dash of x, I find it is 3x square minus 3. Okay, I found this one. So now, what I have to do? Next step, I have to equate f dash of x to 0. This implies I will be getting 3x square minus 3 is equal to 0. Then x is equal to plus or minus 1. Okay, first I take 1. Okay, children, I take 1 at x is equal to 1. So that means I have to check for 1 minus and 1 plus. For which function, children? For f dash of x. I rewrite this f dash of x for our convenience. It is 3 bracket x square minus 1 is nothing but 3 bracket x plus 1 into x minus 1. For our convenience I am writing. Now see, children, what's happening. I am going to file for f dash of 1 minus. That means left of 1 if I substitute, what will have 3 bracket. 1 minus if I substitute means, children, it is lesser than 1 only. Okay, very close to 1 only I am checking. So that means you will be getting this positive. 1 minus. Okay, but it is lesser than 1. Already 1 is greater than that. So you will be getting negative. Okay, that means finally we get it is negative. It is lesser than 0. Okay, children. Now next f dash of 1 plus I am checking. For 1 plus what will happen? 3 bracket. So it is already 1 plus. If you give 1 plus means right of 1. That also plus only. So plus here 1 plus, that will be greater than 1 only. But minus 1 means you will be getting plus only. This implies we get what, children? It is positive. This is greater than 0. So from this what we can conclude here, f dash of what? 1 minus is negative and f dash of 1 plus is positive. It is from negative to positive. Okay, f dash of x is negative to positive means we can say it is minimum. Okay, at x is equal to 1. And the next f dash of minus 1 minus. So minus 1 minus, which means children 3 bracket. Now minus 1 minus if you give means you'll be getting negative over here. But here minus 1 minus, children, this also will be getting negative. So here you will be getting positive. It is greater than 0. Then f dash of minus 1 plus. Okay, minus 1 plus, that means it lies between minus 1 to 0. Okay, but it will be lesser than 1. So here you will be getting positive. Then minus 1, even though it is a minus negative only, so you will be getting negative. That means it is negative. Okay, children. So therefore we can say it is lesser than 0. Now what is happening in this? It is positive to negative. So if it is positive to negative means we can say it is maximum at x is equal to minus 1. So this is how we should suppose find the point of the local maxima and local minima using the first derivative test. Okay, so now we have to find the local maximum and the minimum values for the given function. Children, here I am going to use the second derivative test. First, I will find f dash of x. Now what will be 12x cube plus 12x square minus 24x. Okay. Second, I need to find f double dash of x. I will be getting 36x square plus 24x minus 24. Okay, children. So now f dash of x I have to equate to 0 for maxima minima. So for maxima or minima, I equate f dash of x to 0. So what will I get? 12x cube plus 12x square minus 24x is equal to 0. I take 12 out and x also out. What will I get? X square plus x minus 2 is equal to 0. So then from this we can say x is equal to 0. But for the quadratic polynomial now we have to check with the diamond method, that is multiply. When you multiply it is minus 2. When you add it is 1. That means 2 into 1, but I put a minus here. So this means x is equal to 0 and x is equal to minus 2 and x is equal to 1. This many values I am getting 0, minus 2 and 1. I have to substitute in f double dash of x. Okay, that means children f double dash of 0. What will I get? 0, 0 and minus 24. I am getting lesser than 0. Therefore, I can say f is maximum at the x is equal to 0. Then what is the maximum value? So maximum value is f of 0. So you will be getting 12 only. The next f double dash of 1, that is 6 bracket 1 square plus 24 bracket 1 minus 24. 24 cancel, we get 36, which is greater than 0. Therefore, we can say f is minimum at the x is equal to 1. Therefore, minimum value is nothing but f of 1. So, here if you substitute, it is 3 plus 4 minus 12 plus 12. It is nothing but 7. The next f double dash of minus 2, positive only. Therefore, we can say f is minimum at the x is equal to minus 2. Then what is the minimum value? Is f of minus 2. You can substitute in the function and get it. Absolute maximum and the absolute minimum. I draw the curve like this. Now you can see in 3 points, we can see the maximum. Okay, in 3 points we are getting the minimum. Okay, children. Now these are all in the given graph. Okay, they are called local maximum, local minimum values. Okay, here these are all local maximum, local minimum. You know what is absolute? Among these maximum, which is the largest? So that means this is the absolute maximum. Among this minimum, local minimum, which is the least one? This is the absolute minimum. This is what, children? The difference between local maximum and the absolute maximum. Local minimum and the absolute minimum. Okay, children. So now what we have to do for this? We have given the working rule for this. Find all the critical points. Children, I say the procedure. F of x will be given. You find f dash of x. Just equate to 0. Get x values. Okay, children. Now you know what you have to do. This x value called the critical value. So this value, and they will be giving, okay, they will be giving some point like a comma b. We have to substitute this a, this b, and x value. We can say it is c. You have to substitute all these values in f of x itself, like this: f of a, f of b, and f of c. I am getting only one value I consider, children. So now among this, whichever is the least will be considered as the absolute minimum. Among this, whichever is the highest is called the absolute maximum. Okay, children. Now we see one question to find the absolute maximum and minimum. Whenever they ask absolute maximum minimum, children, they will be giving the interval. In the interval, we can see the first number and the last number. That also should be substituted in f of x. Apart from this, we have to find the f dash of x is nothing but 2 times x minus 1 plus 3, that is 0. That's all. Now what you have to do, children? We have to equate to 0, which implies 2 times x minus 1 is equal to 0, x is equal to 1. Now here, we are having 1. Okay, children? So what we have to do? We have to substitute minus 3 in the f of x function. That means minus 3 minus 1 whole square plus 3 4 square 16 plus 3, which is 19. Then f of 1 we have to substitute. Here it is 1 minus 1 whole square plus 3. It is just 3 itself. Among this, which is greater? 19 is greater. So therefore we can say that f is absolute maximum at x is equal to minus 3. Okay children. So the maximum value is 19. Then f is absolute minimum at x is equal to 1. This implies the minimum value is, it is just 3. That's all children. So this is how we should suppose to the absolute maximum and the absolute minimum. We shall do one verbal problem in this type. Show that the right circular cylinder of given surface at the maximum volume such that its height is equal to the diameter of the base. Children, whatever given, we have to search for the keywords children. If they mention the word given something, no, that is the given clue for us. Then after they mention the word maximum of something, no, that is what the function to be maximized. Okay children. So they have given surface. So given surface. So that means cylinder, no, surface they mention, sir. We have surface means it is total surface area or CSA, like that we will be having question. But if they mention the word surface, it is just a total surface area only. Otherwise for CSA they will mention. So we can say surface area of the cylinder is 2 pi RH plus 2 pi R square. That is it. Okay children. Now maximum volume they mention. So I find the volume V is equal to pi R square H. But here we have the two variables children. To get the maximum minimum, we need to get the function in terms of only one variable. But here I have two variables. To convert that into one variable only, they have given the clue. Here S is the constant. Why S is the constant? Because they mentioned given surface. That means it is fixed. So here we are going to find R in terms of H or H in terms of R. Which is better? You have to choose children. So here taking R common out and then writing R left side, remaining everything, another side means it is little difficult because R square we have, R we have. So what we are doing, we are keeping a H on one side, then everything comes to the other side. That means S minus 2 pi R square by 2 pi R. I take this one. Okay children. So this implies what will we get? S by 2 pi R minus R. Like this, anything can be followed children. Either this you can take it or you can take this one. It is your wish. Now we will be substituting in this. So V is equal to pi R square into, I substitute this itself in the place of H. S minus 2 pi R square by 2 pi R. So then I can cancel this pi and the 1 R will be cancelled. Then what will be getting children? Now I can write S R by 2 minus 2 cancels pi R cube. This is what V. Now see, I got this equation in one variable which is R. We may be sir, S is there. S is a constant, like a number. Okay. Now we need to find V dash. That means it becomes S by 2 minus it is 3 pi R square. Again we have to find V double dash. So that means it is 0 minus 6 pi R. Here itself we can conclude children, it is less than 0 because R cannot be negative. So minus 6 pi R is lesser than 0. Therefore we can say the volume is maximum. Immediately we can say anyway. What we have to do? For maxima or minima. What we have to do children? F dash of x is equal to 0. Here we have to write that V dash is equal to 0. That means S by 2 equal to 3 pi R square. So this implies S is equal to 6 pi R square. Children, whatever we take, if we substitute in V dash, it will be less than 0 only. Therefore, at S is equal to 6 pi R square, I can say V double dash is lesser than 0. Therefore, volume is maximum. Okay, children? Yeah. Next, after we proving the volume is maximum, here they are asking, its height is equal to the diameter of the base dimension. So, I am going to connect that with that. So, at S is equal to 6 pi r square, I check h is equal to s minus 2 pi r square by 2 pi r. Substitute this 6 pi r square minus 2 pi r by 2 pi r. So, it is r square. So, now the numerator become 4 pi r square by 2 pi r. While cancel, you get 2r. This implies, children, h is equal to diameter. Okay, we proved. This is how we should do the sum. Okay, in the word problems, first we have to see the keywords given or fixed. That and all should be used as the clue. Okay, then maximum, minimum, least, largest. Okay, like that and all, if they mention the word, children, that is for the function. That function to be written as a single variable. For that, you should use the given condition. Okay, like here, given surface they mention. Sometimes they will mention fixed circle, fixed sphere, like that and all they will mention. That and all will be used for a clue. So, to make it as one variable equation, and then we have to do the as usual procedure, 1 dash and double dash. Make a 1 dash is equal to 0 and get some value. Substitute in double dash. If you get lesser than 0, it is maximum. If it is greater than 0, it is minimum. That's all, children. This is how we should suppose to do the maximum, minimum. Okay, children. Hope you all understood the chapter application of derivatives. Any doubts you can ask me through WhatsApp. Thank you, children.